So now we are moving to the next simulation approach, which we are going to explore in frame of this topic. And in this section, I am going to talk about agent-based modeling, or sometimes in the literature you could find out a bit different title, agent-based simulation. So in overall, agent-based modeling focus on individual agents, their behavior, and how they are interacting inside specific system, and how actually a following interaction lead to a system level outcomes. Agent-based modeling focuses on individual entities and their behavior, as it was already stated. Here the question is, what actually is the agent? A definition says that agent is an autonomous entity with its own attributes, decisions, rules, and ability to interact with our agents and with environment. So a good example of agents would be people, vehicles, organizations, or countries. Here, most probably, I need to provide the reference back to one slide which we have discussed with a level of the details. So the following example demonstrates really very well why agent-based simulation as approach is located on different levels of a decision making. So one case is when agent is a specific vehicle or person, and totally different story is when agent is a whole country. So the key idea behind agent-based simulation is that global system behavior emerges from many simple individual actions. Okay, so let's go a bit deeper inside. Just to remind you, we are trying to catch up the essence of agent-based simulation. The thing which we have already discussed is the following, that one of the key concepts of agent-based simulation is a concept of agents. And we have identified that agents actually are the entities or individual entities which have their own behavior, which is able to interact. So the following picture, most probably a simple one, but still it visualizes the key concept of agent-based simulation. Meaning that here we have some system or some environment, and inside the environment we have agents. In this case, agents are vehicles. So as you're able to recognize, we have vehicles of different types, meaning that most probably agents have attributes which, at example, could define the different types of the vehicles. Also, we are able to see that there is some interaction between the vehicles, and again, it's really very easy to imagine that when vehicles are are part of traffic flow, of course they are interacting. So the next thing which should be understood regarding the agent-based simulation, that there is an environment, so meaning that agents exists in some environment. Okay, a following picture is really very funny. It demonstrates buildings, traffic lights, trees, or whatever the road, but you should catch up that in overall environment could have a different nature. So, at example, political environment, economical environment, or whatever. And as you're able to recognize, so agents are able to impact environment, but in the same time, the environment is able to impact the behavior of the agents. And here we are coming to a very important thing which I have mentioned, but we didn't discuss it. What means the behavior of the agents? Are we talking about artificial intelligence or whatever? No, I know AI is a hot topic right now, but no, not in this case. meaning that yes, we are describing the behavior of the agents and we're demonstrating the behavior, but we are using quite simple approach. And a following approach goes from a discrete math and known as a state charts or state diagrams, meaning that the behavior of a specific agent is described as a state chart, and as you see, according to the picture, a state chart has the number of states, and by the specific time point, a specific agent is, let's call it, located or is in specific state. So parked, driving, idle, in service. And as you're able to see, there is a mechanism of how the agent could change the state or could change the status. And in each status, the specific behavior of agents is demonstrated. Agents or the specific agent is demonstrated. In agent-based modeling, the behavior is described using states. It's something what we have discussed. But to be honest, a state charts which describes the behavior can be quite complex. Okay, it could be really quite complex. And the following slide is just giving you probably a very generic vision or generic understanding of what kind of states and additional elements in agent-based simulation are utilized to describe the behavior. So a state represents actually what an agent is doing at a specific moment of time. So, for example, a person can be waiting, working, or talking, a vehicle can be stopped, moving, accelerating, and so on. While the agent is inside the state, it follows the rules and actions which are defined by that state. So agents move between states using transitions, okay, the arrows which are demonstrated. Transitions can be triggered by an event, such as a timer expiring, by a specific conditions, for example, a queue length becoming too long, or by some internal decisions of the agent. So using states and transitions, we are able to simulate a very complex and realistic behavior of the real system. Okay, so we have discussed the theoretical concept of agent-based simulation, and I really hope that the essence of the following approach is clear for you. The following slide is dedicated probably to example or demonstration of how actually agent-based simulation can be utilized for traffic flow simulations. So in frame of the course, we are going to explore a professional tool for traffic flow simulation, which is vSim. And vSim, of course, it's just the software, but to make the simulation, a software is utilizing the mathematical model which is called Wiedemann car following model. So according to the title, you are able to catch up that probably a following mathematical model describes of how movement of the vehicles is happening inside the model. So the complex diagram which you see right now, it's not for deep understanding or for deep study, but it represents of how Wiedemann car following model can be described using state charts. And as we have learned, a state chart is something which is describe the behavior of the agent. So meaning that depending from internal and primary external factors, a vehicle could be in a free flow, so meaning that probably the leader, so the car in front is too far to make any reaction. Next, it could be the state follow, meaning that we see a vehicle which is in front of us. Yes, maybe it's again too far, yes, to make any, let's say, to make any changes in driving. Okay, but still we are able to see it. So if we are approaching it, we are making some reaction, so we are braking or speeding or whatever. So if we are too far, so we are braking hard, and finally we are reaching an unsafe situation. So you are able to see, you are able to recognize of how a traffic flow behavior can be represented or could be simulated using agent-based simulation. Okay, so this one is actually not a PTV vSim simulation, it's from our software, but I believe it's not really very important right now. So what we are able to see that a following model is representing a traffic flow simulation, meaning that each, I would like to underline this one, meaning that each of the vehicle which you see here is actually the agent with the specific behavior. And again, if you would move closer, or maybe let me just change a view, you are able to recognize, as example, different types of the vehicles. But in overall, yes, you are able to see that they are demonstrating, I wouldn't use the word a clever behavior, but the behavior which is corresponding to real vehicles. And just an example of, let's call it interaction with external environment, we are able to see that here we have a traffic light, which is actually represents the external environment, which is impacting the whole system. Okay, agent-based modeling has several important strengths, which are indicated here. So probably several of them can be highlighted. So first of all, agent-based modeling or agent-based simulation represents heterogeneous agents, which are capturing the local interactions. And because of the following local interactions, we have an ability to study emergent behavior that cannot be seen on individual level. It is especially useful for the system with decentralized control, learning and adaptation. At the same time, agent-based modeling also has limitations, and again, models can be quite sensitive to assumptions. In many cases, there is quite problematic to complete a validation, so testing of such model, and one of the biggest and one of the most important is a computational, let's say, expenses. I mean that if we are reproducing of a behavior of large populations, I mean populations of agents, most probably in this case we would require quite powerful computers, okay, which are able to demonstrate the behavior of such large population. So in overall, what can be stated that, of course, agent-based modeling is really very powerful as a simulation approach. But again, I would like to underline a very important aspect that usually agent-based simulation is utilized when we need to represent individual behavior with a significant amount of details, which in some cases actually not, let's say, not necessary if we are considering specific goals. So we have discussed two approaches: discrete event simulation and agent-based simulation. The following slide is probably key takeaways from the following discussion. As you are able to recognize, one column is dedicated to discrete event simulation, the second one is dedicated to agent-based modeling, and this one is actually represents in a very narrow form comparison of both approaches, considering some aspects, like at example primary focus, and here is indicated for discrete event simulation processes, workflows, while for agent-based it is agents, and so on. So I believe this one is really a good table which indicates the key difference between the approaches. So I'm really recommending you to spend a bit of time to see if you catch up the key aspects of both approaches.